everybody, my name is Ali and today we're going to be building a 2D platformer using pure Python as well as Takinter. Okay, to start with, I'm actually just simply going to show a showcase of the game. Let's start here. And I'm basically just going to talk about what's in this game and how we're going to go about doing this project. Basically, I prioritize object-oriented programming in this game because I felt like made it more organized, predictable, and most importantly, expandable. Because the thing is, when you deal with stuff like movement, collision, gravity, things can get pretty messy very fast. And I felt like, although it adds another layer of complexity here, it just makes everything feel less chaotic. It's kind of like splitting an army into different divisions, if that makes any sense. And as you can see here, we basically only have this player that is moving on different platforms. There's no actual UI to start the game, or a score system that works on different criteria. Like when we jump here, there's no moving platforms that takes us up and spawns new platforms. And the reason for that is because we have all of the main logic down. Like we can generate these platforms at will whenever we want. If we decide to expand, we can make these platforms move. We can make score work, but like the higher we go, the better the score we get. And yeah, that's basically it. And to make all this clear, I'm gonna show a few charts I made to help you visualize how we're actually gonna go about this project. Okay, so in this game we have four main classes. The first one, which is the game, it composes all the different classes inside one class, allows us to create an instance of it, and abstracts all the different parts of the game to the user. Then we have the player class, which is the person, and then we have the platform class, which is the green boxes you saw at the beginning of the video. And then you have the physics class, which is actually abstracted and contains all the actual functionality or logic in the game. Things like movement, collision, gravity, and all of that stuff. And then basically, this is just, I don't know, small boxes to show you the different parts of OOP in this project. We have the physics class, which we only actually ever use in the person class. And if you want to add things like multiple platforms that move, you would also inherit from this physics class as the person does, and you get access to all the movement and gravity that the physics class brings. And then the composition of this project, basically you have the game that spawns in multiple platforms using defined algorithms, and just the player. And yeah, that's basically it. Okay, and let's actually start programming this project. The first thing we're gonna do is import the tkinter library, which is native to Python. It's a UI library that allows us to create window as well as canvas to draw on for our game. And let's just rename this to TK for simplicity. And this window is going to take in a canvas that has a defined width and height. This canvas is basically the place where we actually draw the UI on. And to do this, we're just going to set two global variables because we're going to use it a lot. It takes in a value in pixels. In this case, they're both going to be 1200. And then, before I talked about there's going to be four main classes, the first of which is going to be game. This takes in the parent object. You can leave that out if you want. It's already default. Let's just define the constructor. And the first thing we're going to define is self.root. And basically what this does is creates a window in memory. Like, you know, when you open an application, you get this sort of window, you know. This is exactly what it does. We're going to do tk.capital T tk. This just creates a window in memory. And then, as I said before, this window takes in a canvas which you can actually draw on. Do self.canvas equals tk.canvas. And in order for tk to know which window we're talking about, we simply use the ID that is given back by this here. This gives back an ID in memory, and we do this self.root. There you go. Then we're going to set the width to it as width, and then the height as height. And then let's just background black. Okay, now in order to actually display things to the canvas, there's one thing we need to do. Now this is kind of a niche subject in TK. You don't really need to understand it, but we're gonna do self.canvas.pack. This just allows us to display geometric functions on this canvas. You can ignore that part. And to actually detect whether something is going on to the canvas, like if somebody is pressing something or pressing the W key, we have to start a main loop which detects all of these. To do that, we simply do self.root.main loop. This basically listens, it's like an event listener if you've used JavaScript. It listens for anything you want it to listen to. Now, this does, as I said, listens to things, but to actually update the canvas when that thing happens, we have to define a function. What this function does is it updates the game, redraws everything based on the function we create after a set amount of time. This is gonna do this right now. We're gonna expand it later to update game, and we do this self not root dot after 16. This is the milliseconds as you can see above. It's gonna take in a function that's gonna do update game, and here above we're gonna update the things that we need to update, which is gonna be simply the person. And that's it for the game object. Okay, so now we've created the game object, which just composes the whole game. Now we actually need the main functionality, and for now I'm gonna leave this very simple. It's gonna be class physics, and it's gonna take in the object. You can leave this empty again. Gonna define the construction, and for now we're just gonna put two variables. Now, as we know, in real life physics you have velocity, and this is gonna help us basically simulate movement. We're gonna do self.vy, which is vertical velocity. It's gonna be 0 for now, and self.vx is gonna be also 0 right now. Basically what we're gonna do is I'm saying basically a lot. After a person presses the left key, we're gonna set this vertical velocity to -15 or 15, and then we're gonna increment it by a set amount. And this might seem very confusing right now because it really is, but don't worry, I'm gonna clear it up very soon. And actually, wait, just gonna correct something really quick. We forgot to put in self here, that's why we're getting these yellow errors. Okay, now for the final class, it's gonna be the platform class. Class, platform. This is gonna inherit nothing. Although, if in the future, at the end, you wanna add moving platforms, you're gonna have to inherit from the physics object because it actually has all the collision and movement properties. Let's just initialize it, in it. Also, this is gonna take in the canvas, the x-axis, and the y-axis. And let's do the same as we did before. Self.canvas equals canvas, self.x equals x, self.y equals y, and self.width, let's put it 200 pixels, self.height equals 200 pixels, self.color equals green, let's do green. And also we're gonna have to create this platform, def create platform. Let's put on self this time actually, and as we did before, self.canvas.create rectangle, self.canvas. This is the ID of the canvas because, as I said before, you can have multiple canvases. And let's do the same thing as I explained. Self.x, the starting value, self.y, the starting y value, and to where it goes to, self.x plus self.width. So from 300 to 500, and then same on the y-axis, self.y plus self.width, and the color bg equals self.color. And that's all the 4 classes initialized. And now we're actually gonna create a few instances of all these objects to get some visual feedback. And there's gonna be multiple platforms, so we do self.platforms inside the game object, which is the main composing object. It's gonna be an array, and for now we're just gonna set one platform manually. It's gonna be the standing barrier at the bottom. It's gonna take in platform and canvas, pass in the identifier that we created, and then it's gonna take in the x value, which is gonna be 0. The y-axis is gonna be height minus 300, and because if I set this just normally, it's gonna be at the bottom right here, and we do not want that right now because I'm recording. And then it's gonna take in the width, which is gonna be 1200, or width as we defined, and height is just gonna be 150. then actually we're gonna create this on the canvas because we created an the method for it, if you remember. It's gonna be self.platforms equals no self.platform 0, the first one, simply ground dot create platform. Now here, for you it should be self.canvas. We'll actually remove that first parameter because it's incorrect, and here instead of bg, just simply put in fill. That should fix everything. And yeah, if we create an instance of the game right now, it should work completely fine. There we go. As you can see, this is how it's gonna look like. We have the barrier at the bottom, and now let's create the person. And to do this, let's get the middle x of the ground. So ground x, it's gonna be the width divided by 2 minus the width of the player divided by 2, because if the width is 1200 and the player is 50 pixels, just we're gonna start the player at not 600 but 575. So minus 25. Ground y is simply gonna be, I believe, height height minus 300 minus 50. And then let's create the person. So self.person equals person. It's gonna take in the canvas identifier, self.canvas, then an x, ground x, then a y, ground y, and then oops, there seems to be something wrong here. Oh. Okay, then we're gonna do self.person dot create player. Now, pretty sure it should spawn it incorrectly. Yeah, there you go. Now, obviously, right now there is no movement, so that's what we're gonna do in the next part. Okay, guys, let's pick up where we left off. Now we're gonna work on the movement, and to do that, first we're gonna have to define the default keybinds for movement. Now, to do this, we do self.root.bind, and this is gonna take in what we actually want to bind for a certain key press, and the callback function. So here we want to listen for any key press at any given time, and we take in a callback function which we're just gonna call on self dot on key press, and here we're just gonna do on key release on key release. Now let me just define these two functions here. Def on key press takes in self. My bad. On key release also takes in self. Okay, now there's one more thing. When this is called, it passes in another parameter which describes what exactly happened. And in this case, it's gonna take an event, both of them, and it's gonna have the key that was pressed. Let me just add pass here because I hit this error. So simply all we do is check which key was pressed. To do that, we do if event dot key symbol, like that, equal to, let's do left first, then we do something. We're just checking what key was pressed. Very easy. And what we do here is self.person dot vx equals -5. Now let me just actually explain what is going on here. Now in real life there's something called velocity. It determines how we move. In a game there's nothing really like that. You just simply move it with pixels. To help you understand it better is, say let me just redo this here. Say we had a player right over here. He's at x equals 300, and we want to move left. The way we do is that every frame we update this person and increment a certain amount of pixels to the x value of this person. And in this case, the set pixels we want to increment are simply the velocity on the x-axis this time. So let's say it's 0. On every frame, it's gonna check, okay, what's the velocity on the x-axis? It's 0. It adds 0 to the object.x, person.x, and it stays at the same place. When we press the keybind left, for example, it's gonna be x equal to -5. And so when it's updating this person, it's gonna check what is Vx, it's -5, and it's simply gonna make person.x equal to 300 minus 5. So this is gonna become 295, so it's gonna move 5 pixels to the left. And if you wanna move right, it's simply positive. And that's it. Now let's do the same with the right key point. Make this +5. There we go. And here on key release, all we want to do is if event.keysim is in, I'm gonna make this a tuple, left, left, right. So if it's either one of these, all we want to do is set the velocity to 0. Stop person.vx equals 0. Okay, great. Now let's go over to the physics. Now, as I explained in the drawing, now we actually want to do the checks. I'm just gonna call this def move with collision. Now this is gonna be the biggest function, but for now it's gonna be very simple. I hope. It's gonna take itself. It's also gonna take the object that we want to move. It's gonna take in platforms later. Actually, I'm gonna add that later. And there we go. And the way we want to do this is here. Let's say let's say there's a box like at 303 pixels. Okay. When this moves 5 pixels to the right, it's gonna increment the x value by 5 pixels. It's gonna collide with this. So what we're actually gonna do is make a loop that simply checks, no, not simply checks, it loops one by one to check for collision. Now this is not something to worry about. I'm just gonna explain why we use a loop. And I'm gonna set a variable dx equals to self.vx, and while dx does not equal to 0, we're gonna do something. Now, as I said, we do a while loop to check 1 pixel at a time. So the amount of pixels we're gonna check at a time is gonna be 1. You can make this as much as you want. This decreases performance, but it doesn't really matter. We're gonna do step equals step. Wait, I should have made this capital. If dx is greater than 0, and if it's less than 0, that means we moved left, so it's gonna be -5. It's simply else it's gonna be negative step. There we go. And let's just do the movement. Object dot x equals minus plus equals step. It's as simple as that. Literally, there's nothing more. Now it's time for the y-axis. And it's definitely here. Oh, this is not indented, but oh yeah, this should just be the normal step because we don't know if the value is negative or positive. And I think another error we got is that here we're passing in self.playable. That's just an ID to an object inside the canvas, just a UI. So we want this actual person object. So now let's cross our fingers. It should work. Oh, there you go. Everything working fine. And now let's do the y-axis. So when we want to move upwards, all we want to do is check if the space key was pressed. Then key sim equals space. Then we just set the self dot person dot vy equals to -15 because we want to move upwards, so from 300 to 285 for example, and we won't have a check for the release because we want this to be there's gonna be gravity, so it's gonna be constant anyway. There's no point in removing it. And here no, here we're gonna do the same thing, but instead we're gonna do this with the velocity. So dy equals self dot vy while dy is does not equal 0, step equals, let me just copy this, same thing, then object dot y equals plus equals step and dy minus equals step. And if actually here there's a problem because the initial value, because I did this in previous recording, it's gonna be 0.5, and if you minus by 1, it's gonna be negative 0.5, and this is still not 0, so it's gonna go on, and dy is negative, so it's gonna be sorry, positive, so it's gonna go back to 0.5. It's gonna be an infinite loop, so we have to do a check if absolute if absolute value of dy is less than step, then all we want to do is set step equals to dy minus equal step, and now this should work. Well, dy does not equal 0. Oh, forgot this semicolon, and we have to indent this. Boom, there we go. And here we see this is gonna stay going, and the reason for that is because we never have a force to counteract this. So what we're gonna have is gravity, which is gonna increment the self.vy by a certain amount. So if it's -15 on each frame, we're gonna add 0.5. So apply gravity. We're gonna call this inside the person. It takes in this self, and self.vy equals plus equals gravity, self.gravity. So basically, if our person is right here, and we jump, it goes to about there, then we'll apply gravity, and it goes only a small bit amount until it reaches 0, and it stops, and then it's gonna be negative, I'm sorry, 0.5, positive 0.5, so it's gonna go back down, back down, back down, until we hit something, and when we hit something, there's gonna be a collision check to counteract the gravity force itself. And also here, since we don't have collision right now, but in the original version where I tested it, there's no debounce yet for the space key, so we can just keep on jumping and jumping and jumping and eventually adding more and more and more. And the way we can fix that is simply adding a debounce. We do that by doing this. Self.can jump. First it's gonna be true. And then also here we forgot to add self.gravity, and we did not test it. So let us test it. Yeah, see? Just falls down. Let's check self.apply. Oh yeah, self.can jump equals true, and here once we press it, we're gonna make it self.person.can jump equal to false because he's in jumping right now. And here when it's done, self.can, no wait, no, where do we put this check? I'm just gonna put this here for now, can jump equals true, but I'm pretty sure this is wrong. I'm gonna fix it later. Anyways, that's the y-axis. Sorry guys, I had to cut the video. I showed something private on Google. So now we want to do collision checks. And the way we do that is as such. Actually, let me make this a new function. Def, oh, the space is annoying me. Def check collision. It's gonna take in self, P1 and P2. The two platforms you wanna check collision between. And it goes as such. Now you can take your time to understand this. P1 dot x plus P2 dot width plus P1 dot width is greater than P2 dot x, and P1 dot x is less than P2 dot width plus P2 dot x, and P1 dot y plus P1 dot height is greater than P2 dot height plus P2 dot y plus vertical gap, because we need space for the person to jump, and P2 dot no and P1 dot y plus P dot height is less than P2 dot y plus P2 dot height plus the vertical gap. There we go, very long function, and I think that's how it's supposed to be, I'm pretty sure. Basically this one checks if platform 1 is to the right of platform 2, and if that's true then it cannot possibly be to the left of it at the same time, because then it would be colliding. This check does that, and then it checks if there's enough space between platform 1 and platform 2 for the player to jump. This is to the above one, and this is to the down one. Now here we're gonna check between the new platform and any already existing platforms in the platforms array over here. So what we do is, if not any, I'm gonna do a lambda function here. Self dot check collision between new plat and b just plat for plat in self dot platforms. Perfect. If there isn't any, what we do is simply append new plat, self dot platforms dot append new plat, and then we want to draw this platform, and then we're gonna decrement count by 1, because that means we found one of the existing 10 platforms that we need. And let's see, yeah, now we have to call it. My dad walked in. Anyways, let's pick up where we left and check this. There's only one. Why? Because I did not add the while. I'm not sure if I explained this or not. I forgot. Count is not equal 0, and because we're gonna make 10 platforms, and here we decrement the amount of platforms we have generated by 1. So once we find one that's compatible, we minus it by 1 until it reaches 0, then we don't need any more. There you go. These are way too long in height, so let's check here in the platform. Self.x, self.y, self.x plus self.y, self.y plus self.y. Ah, was supposed to be height. Funny mistake in it. Okay, nothing is colliding, which is great, but actually there's things that are colliding, and this means that the collision algorithm is wrong. So maybe in the height, P1 high plus P2 that high. This is checking above it, so it's not supposed to be like this. Here it's, but however no, we do not need the height. This is just adding useless things since the height is downwards anyway. And here, same thing, we don't need the height. And this is checking down, so we do need the plus. Wait. This one's not needed. This is needed. let's check. Okay, this is good. This is good. Nothing is colliding, but see here, we don't have enough space to jump through, and the reason is because we are not accounting for the width of the person. So here, all we have to do, since this is checking if it's to the left, then that means we minus 50 to this side. So minus 50. This may be a bit hard to understand, by the way. I sat like for an hour trying to find a suitable algorithm when I was first creating this game, and here, um, we can add 50 minus 50 or whatever on both sides. We can add it over here. Wait, no, over here. Obviously, you cannot add on both sides, you moron. Alright, perfect. There we go. Finally, that is collision between platforms done in random generation. Finally. Now, all we have left is player between platform collision. Welcome back, ladies and gentlemen, after your 0.5 second break. We're finally in the last part of this small project. And first thing I'm gonna do is grab this whole function here, because we're gonna need it. Same exact thing, but we don't have to account for all that yada yada. Remove this and this. Yep. And now vertical cap. There we go. There we go. Whoop. Up. There we go. What is going on? Perfect. Now, I'm gonna do the vertical check first. Now, there's two ways to do collision between moving things and stopping them. First, after you move the person. Okay, why are there two arrows? Where is this? Why is this here? Oh, no, 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 no. No, 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 no. This is still untouched. Okay. After swift arrow. Please let me just. I'm wasting your time, guys. Sorry. As I was saying, there are two ways to do collision in a simple game like this without doing something like raycasting. First one is after you move, you do collision between the player and every single platform in the game, in a specific range. And if they're colliding, what you do is TP the player back to where they were, and we do this by, for example, if we are colliding with something above us, we simply TP put, which means putting the Y value directly to the Y value of the platform you're colliding with plus its height. So it'll be like, for example, like this. Okay, I collide, we TP right over here. And if you're colliding from above, you simply TP to above right there. And if it's from the side, you do like whoop, you can simply TP it over here, and same thing like over here. Okay, so how do we implement this in code? Oh boy, buckle up. Just realized something. Beautiful, beautiful, right? Beautiful, absolutely beautiful, magnificent. We're gonna do this, okay, for platforms. Remember, this takes platforms. In platforms. Self, let's just check collision between object and the plat. If there is collision, we would check if you are moving to above or to down. If it is less than 0, then that means we are going up, because as we said before, to go up you add a negative force. So that means we have to TP downwards. Let's just start with the positive one first. If step is greater than 0, all we simply do object.y equals to plat.y plus plat dot width the height. Yeah. Object.vy set the velocity to 0 to cancel it out, but this is kind of negligible because you still have gravity. Object.can jump equals to true. We're gonna do this at the end anyway. But okay, now we have the else statement. I'm so tired now. Object.y simply equals flat dot y. Wait a minute. These two can't be the same. Wait, let me. Greater than 0. Oh. We minus it because we're falling down like this. Say this is like 300 and this is 50. Object. Alright. That is splendid, absolutely beautiful. And set the object of I. We can just put this up, but I'm too lazy to do so at this point. Equals 0. Splendid. Absolutely splendid. This should work. I don't see why it would not work. Okay. Oh. See, look. Okay. Now we just have to do the x-axis collision. Oh my god, that is so beautiful. Genuinely. The most beautiful thing ever. What? Okay, so debounce isn't working. That's another issue. We're gonna fix it then. For now, let's just repeat the same exact thing here. But instead of y and vy, all we do. Okay, here. Object, no y's, x, vx, dot width. Beautiful. Okay. Don't you just love it when that happens? Okay, so that collision is done. Let me just take a small break to recoup my energy, and then we can continue. Okay, I am back from my dinner break. Okay, I think it's definitely here because this is so redundant. What is it? Okay, so this is just doing it at the same time. No. What? No. Well, bet you look at that. Balls! Despicable. Okay, let's just make our way up here. Now, obviously, this is still not working. Um, Let us see. Okay, so we have person here that has person that can jump equals true. On space jump, we set it to false, and this function happens. If step is greater than there's a collision, we teleport them. Let me just set this to false again. False, false. So maybe that changes something. I'm gonna take a small break to fix this. Okay, guys, so actually everything was correct. Has nothing to do with here. Here, there's a check we forgot. Where is it? Where is it? Right here. This just completely ignores the purpose of can jump and self-not person that can jump. So if they can jump, you won this. And I think we're done. Okay, that is beautiful. You now have your platforming game. And I think this vertical gap is way too high. So let's do 75. No, wait. I don't think the vertical gap is the issue. It is it's the vertical gap. Okay. Really, mate? Really? Okay. This one is a hard one. Uh-huh. 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 Everything is possible. Now, you can expand to this as much as you want. You can make a start menu. You would have to use more advanced take enter stuff with that. You can add a score system, which would represent the Y value. And as you go up, for example, over here, you would simply move the platforms down and generate a new platform, so on and so on. It would be a very fun game. Now, guys, that is it for this video. This is one of my first videos ever, so please do mind me. And also, we forgot to add this border, but that doesn't matter. Nice seeing you guys. Not seeing you, you're seeing me. Well, yeah, you get it.